By request, section 10.2, number 19, we're supposed to find the points on the curve, on this parametric curve, where the tangents are horizontal or vertical. And so to do that, we have to remember that dy dx, its derivative, is equal to dy dt, or in this case, dy d theta, over dx d theta. We know we have vertical tangent lines when the denominator is 0, but the numerator is not. And we know we have horizontal tangent lines when the numerator is 0, but the denominator is not. So let's go ahead and just solve those as two separate pieces. So let's take a look at that denominator, dx d theta. That's just a negative sine of theta. So we happen to know that's going to be 0. So dx d theta will be 0 when theta is equal to any multiple of pi. That's just from our trigonometry. And now we'll go ahead and take a look at dy d theta. Dy d theta is negative 3 sine of 3 theta. And we know that dy d theta is 0 when 0 is equal to sine of 3 theta. Or in other words, when 3 theta, 3 theta is equal to any multiple of pi. So let's see, that means that theta would have to be a multiple of pi over 3. So there is where our possible horizontal tangents are, and these are where our possible vertical tangents are. Now, if you take a look at those two cases, they do overlap significantly. Actually, wherever we have the possibility to have dx d theta to be 0, which is at pi, 0, 2 pi, 3 pi, 4 pi, negative 12 pi, and all that stuff, those are identically the same times when some of these points match up, right? So if you take a look at, for example, in this case, I should call this k bar. If k bar is equal to 3, then theta is equal to pi. However, if k is equal to 1, we happen to know that at pi, that denominator, dx d theta, will also be 0. So we have possibilities where we have these 0, but are they 0 at the same time? And the answer to that is they can be, right? So if you take a look at this derivative, dy dx, it is actually, again, dy d theta over dx d theta. So dy d theta, again, is just a negative 3 sine of 3 theta. Dx d theta is sine of, technically a negative sine of theta. When theta is 0, you'll have 0 over 0. When theta is, actually, maybe I should write that in. Theta equals 0 implies 0 over 0. Also, theta is equal to pi, which is the same thing as 3 pi over 3. We get 3 pi over 3 times 3, or sine of pi, which is 0. And again, sine of pi downstairs is 0. And when theta is equal to, let's say, 2 pi, right? Or actually, I don't think 2 pi would work out. How about 6? Actually, yeah, we could do like this. We could say, what if theta was 2 pi, right? The denominator would be 0. The numerator would be sine of 6 pi, which is also 0. And you can see that basically anytime that we hit a multiple of pi, we've got an issue, right? And so we have to throw out all constant or all integer multiples of pi. So all these integer multiples of pi are thrown out. And so you'll never actually have a vertical asymptote. However, you will have horizontal asymptotes because remember, you get horizontal asymptotes when dy d theta is equal to 0, which is any multiple of pi over 3. Well, we have to throw out third multiples, right? Because 3 pi over 3 would be pi. Well, we're not allowed to do pi or 0 or 2 pi. So basically, any multiple of pi over 3 that is not divisible by 3. So that would be Did they give a domain restriction on this problem? I'm going to just double check because if they did, that would be a lot easier to state. Nope, they didn't. So let's see. We have horizontal asymptotes or horizontal tangents, I should say, not asymptotes. There we go. Sorry, I'm blanking on how to spell horizontal tangents when, or maybe I should put it this way, at any multiple of pi over 3 plus 2 pi k, that's what I'll write, or 2 pi over 3 plus 2 pi k. Actually, it should be plus pi k on both these. I'm thinking about it, right? Because if it's plus pi k, you'll see that you miss all the standard integer multiples of pi, right? So when k is 1, that'll be 4 pi over 3, and when k is 2 is 7 pi over 3, and so on and so forth. But you never get to just pi, or 2 pi, or 3 pi, and same thing with this one. So these are when you have horizontal tangents, there's no vertical tangents. So I can just write vertical tangents, none. Okay. So again, the idea behind this is to take a look at your parametric equations, take their derivatives. You want to make sure they're not both identically zero at the same time. So in this case, we just found out when each was zero, and then we took a look at their overlap. They overlap at every integer multiple of pi because, again, that denominator goes through pi over 3, then 2 pi over 3, then 3 pi over 3, which is pi. But that overlaps with this. So there you go.